Hi, good morning. Today we will see dimensional analysis, which is in heat transfer phenomenon as well as in fluid mechanics phenomenon and other physical phenomena. This dimensional analysis is very important for developing the equations or for developing the relation between the various variables involved in the physical phenomenon. Let us see what is dimensional analysis. So, dimensional analysis, no, the the study of the relationship between the physical quantities in the form of an equation in a physical phenomenon with the help of dimensions is termed as dimensional analysis. So if you take any physical problem, if you take any physical phenomenon, in the physical phenomenon a number of variables will be there. So in the physical problem, suppose n number of variables are there means, so if you want to develop a relationship between these variables means, in the form of an equation, if you want to develop a relation between the variables in the form of an equation means, with the help of dimensions, no, that kind of study is called as dimensional analysis. So it is a tool. Dimensional analysis is a tool. With the help of this tool, we can find the equations, can establish the equations, we can find the equations to develop the relations, to develop the relations, to develop the relations. So by make use of dimensions, by make use of dimensions. This is called as dimensional analysis. Dimensions. So dimensional analysis is nothing but a tool. With the help of this tool, we are able to find the relation between the variables in the form of equations. So we are developing or establishing the equations for a given physical problem. There are two methods will be there for dimensional analysis. One is the Rayleigh's method. The other one is Buckingham's pi theorem. So Rayleigh's method means the number of variables will be, number of variables are limited only. Variables are limited. Say for example 3 to 4 only. If it is more than that, now we can use Buckingham's pi theorem. Suppose if you go with the Rayleigh's method for more number of physical quantities or variables means, it is very difficult or confusing for Rayleigh's method to handle all the variables. That's why the number of variables are limited to only 3 to 4 only. Next one is Buckingham's pi theorem. No, so it can handle more number of variables, more number of physical quantities or variables, more number of variables. So these are the two methods we are having for dimensional analysis. Two methods we are having for dimensional analysis. Next one is the concept we are using here is principle of homogeneity. To take any equations, if the equation left side and right side, suppose if they have same dimensions, then the equation is said to be dimensionally homogeneous. So it states that dimensions of each of the term of a dimensional equation on both sides should be same, then the equation is said to be dimensional homogeneity. This is the principle we are using in case of dimensional analysis. Let us take one problem, a simple pendulum problem, which is using Rayleigh's method. Rayleigh's method or a Rayleigh-Ritz method, both are same only. A simple pendulum now. So here time period is a one variables, length is one variable, and acceleration gravity is one. Three variables are there. So therefore we can apply the this Rayleigh's method. We can apply the Rayleigh's method here. So here now time period is called as dependent variable, and other variables L and G are called as independent variable. This is called as independent variable. This is called as dependent variable. Therefore, the dependent variable can be written as time period is proportional to length power A, and time period is proportional to G power B we will take. Therefore, we can write time period is proportional to L power A, G power B. If you remove the proportionality, now we have to introduce some constant that is called as proportionality constant. Time period is equal to k into L power A and G power B, where k is called as a constant, proportionality constant. So here now the dimensions of time can be written as m power 0, L power 0, T power 1. The dimensions of length can be written as L power 1, m power 0, T power 0. The dimensions of G can be written as L power 1, m power 0, T power, this is minus 2, T power minus 2. So these are the m power 0, L power 0, T power minus 2 will be the dimensions of acceleration due to gravity. M power 0, L power 1, sorry. M power 0, L power 1, T power minus 2 will be the dimensions of acceleration due to gravity. Now let us take this equation, that is T is equal to K into L power A, G power B, and apply dimensional homogeneity. So for L power A, the time period is equal to some constant into L power A, G power B. No? So for a time period now, the dimensions will be L power 0, M power 0, T power 1. Here now for constants, there is no dimensions. For L now, L power 1, whole power A. For G now, LT power minus 2, whole power B will be there. Now, it is L power 0, M power 0, T power 1. So here you will get L power A plus P, and here you will get T power minus 2B, because this L and this L is, you will get L power A plus B and T power minus 2B, and M power there will not be any terms, M power 0 only. Now bases will be same, therefore powers will be equal. That means you will get A plus B is equal to 0. Next one is 1 is equal to minus 2B. So that is implies you will get B is equal to minus 1 by 2. So substitute B here. So in this equation you will get A value. A is minus B, that is minus of minus 1 by 2. So the value of A will becomes 1 by 2. Now substitute A is equal to 1 by 2 and B is equal to 1 minus 1 by 2. The equation time period is equal to K into L power A, G power B. So here you put A is equal to 1 by 2, B is equal to minus 1 by 2. Then the equation will be simplified as L power T is equal to K into L power 1 by 2, G power minus 1 by 2. So here that can be written as T is equal to K into L power 1 by 2 is called as root of L by G you will get. Now by doing the experiment now, if you know the experiment, if you do the experiment, we can find time period, we can find the length, we know the acceleration due to gravity, that is 9.81, and finally we can able to find K value from the experiments. So experimentally we can find K value. So by knowing the time, length and G, we can find K is equal to 2 pi. So finally we can develop the expression for time period is equal to 2 pi root of L by G. So like this we can develop the expressions for the various variables involved in the physical problem. I hope you understand this problem. Thank you for watching the video. For more videos you can subscribe me at this channel at THPRASADS in the YouTube channel. In the YouTube you will get this one. Here you can subscribe. Thank you for watching. Thank you.